So, good afternoon, everyone. I welcome you guys to this online live interaction on NPTEL online course education on mass transfer operations. So, this is the week first of this online live interaction with me. So, before I begin, I'd like to just give a quick view who am I and what we are going to do through the entire course duration for this semester and what we are going to do for this online live interactions. Okay, just 1 minute, guys. Yeah. So, So this course is based on this mass transfer operations. That is the basic course that has been offered to the chemical engineering undergraduates, and it's one of the major core courses that undergrads has to go through for the chemical engineering degree, and it's been have been very dominant effect in the case of the industrial uh, problems, solutions, and many more. So what you're going to do in this the entire tenure of this course, that is from starting from today till November or October, we'll be going through the various tutorial problems, assignment problems, and we will try to solve out every assignment's problems. And even if you guys have some problems in solving the assignment solutions, anything, please let me know through this online live interaction, as well as you can also submit in the feedback portal through the SWAYAM NPTEL. So let's begin. I will wait for like just few minutes. It's almost like few of the guys would like to join. Okay, let's begin. That's not a problem. If something wants to join, they can join in between. So before I begin, just a quick introduction of myself. So welcome you guys on this live interaction on mass transfer operations. So this course has been offered by Professor Mandal, who is a professor in the Department of Chemical Engineering at Indian Institute of Technology, Guwahati. So this course has been offered by him, and it's all the lectures have been on the NPTEL. What I will be doing is that I'm the course TA for this course, that is Mass Transfer Operation 1, and myself being I'm the teaching assistant. My name is Rajput Shubham Kumar. I'm a PMR scholar, that is Prime Minister Research Fellow in the Department of Chemical Engineering at IIT Madras. So I will be your TA through the entire tenure of this course, that is from starting from today till October or November, and we'll be having these live interactions every weekend, that is on Saturday at 3 to 4 p.m. for 1 hour. Just a minute. So, okay, for those who joins this recently, it's like I just gave a quick view. So we are having these live interactions, and being the TA, I am Rajput Shubham Kumar, and I'm a PMS scholar in Institute of Technology Madras in Department of Chemical Engineering. So I will be your TA through the entire tenure of the course. Okay, so before we begin, like mass transfer operation is one of the, like I said, it's one of the basic core subject of the chemical engineering undergraduates, and it can also be studied in mechanical engineering also, because many of the problems associated with the mass transfer can also be done in mechanical related situations also, as well as in the chemical related situations also. So in order to do this basic fundamental studies and various courses, like we also, there is another course called heat transfer. Similar to heat transfer, there is another called mass transfer. So what we're going to do is to study the basics of the mass transfer, because this is MTO1. There are other phases that are high-end version of mass transfer operation, that is mass transfer operation 2. But what we're going to study is how this mass transfer is going to play a key role in the industrial processes related to the chemical engineering, as well as to the mechanical engineering also in some sort of view. But for main focus will be on the chemical engineering and how to relate mass transfer in chemical engineering to the industrial aspects, and how to solve the various aspects of the problem arising in day-to-day world of the industries. Okay, so if you guys have gone through the week 1, you might have heard of these basic concepts. What is mass transfer? What is diffusion? What are the laws of mass transfer? That is first law, second law. Similar to heat transfer, there are laws of mass transfer also, which are called as fixed law of diffusion. Before going to the fixed law of diffusion, we will see what is mass transfer and why we want to study the mass transfer in industries. Okay? And similarly, there are laws for mass transfer, and apart from them, there are, as we proceed through the tenure of this course, we'll try to pick up in the later stages. But for today, that is for the week 1, it's only for the basic course overview. What you have guys have gone through the lecture notes, as well as on the assignments, like assignment 0 and assignment 1. It's already been uploaded, and assignment 2 has also been uploaded on the NPTEL portal. So we will going through some of the basics, like what is mass transfer, laws of mass transfer, and like the third topic which I have gone through, like in the that has been in the week one decline in the NPTEL swim portal. It's steady state molecular diffusion in fluids under steady and laminar flow. So and the third is the tutorial. Fourth one is the tutorial problems. So for the week one, what I would like to suggest is that we just go through the basics. What is actually the subject is about, and we'll just solve like 3 to 4 problems today. That's why, because I want to build up like a strategy, because if I directly start solving problems for the first week itself, you're not able to cope up with the concepts what we are dealing with in the lectures, and as well as the video what you are going to see in the upcoming courses. So it's better to go through all the basic concepts, then we try to solve some problems. Okay, before this I like to someone to speak out, because it's like only I'm interacting and no one is interacting at all. So can anyone speak out from which college they are, and why they choosing this course? Just like quick, like 1 or 2 lines. Anyone from the students, can you speak out, or should I want to pick up one? Anyone? So don't yeah, please go ahead. Yeah, please go ahead. Okay, Anna University. Yeah, okay. Okay, you are in the semester 5 undergrad. Okay, great, great, good, good. Yeah, anyone else want to speak out, so that I will get an idea, means in which, like, if it's from the different departments or only from the chemical engineering departments. So it will helpful for me to also to collaborate all the basic courses from the chemical as well as from the mechanical also. Yeah, please go ahead. Yeah, Majid. Okay. Sorry, which college? Okay, okay, okay. So you're in the petrochemical engineering. Great, great, great. Yeah, that's not a problem, because I'm also doing my post-graduation studies in petrochemical engineering. So that might not cause any problem taking this course, because since mass transfer is related to all the courses as well as to the various fields, so it's just like anyone can take this course. It's not like related to some departments actually. So that's not a matter. Yeah, great. Good to see like different varieties of disciplines students have been joining this course on the NPTEL in order to get gain in experience on these related fields. Yeah, that's great actually. So before we start, like I said, this week only I'm going to this live interaction only. I want to say what is the basic. From the next week, we'll start solving some of the problems. So I will be doing like I will be solving each and every assignment problems, not each and every, but one which are very difficult to solve out using this online modes. So what I'll do, I have my pad, so I'll solve each and every questions, particularly specific to the assignments only. And if in case you want me to solve any other problems that you are facing, problems, issues, even if they are not related to the assignments, please let me know. I will try to solve it out happily. So, but for these live interactions, I will try to solve out all the assignments and the tutorials problems what has been given to you in this NPTEL SOM portal, but only after the due date has been ended. I will not solve any problems before the due date, because it will be against the law of this NPTEL SOM portal. So let's begin first of all. So like I said, what is mass transfer first of all? Why we are going to study this mass transfer operations? Because entire course is based on this mass transfer. So anyone wants to speak out why you are studying this mass transfer and what is mass transfer? As you guys have already gone through the week one course on the NPTEL. Anyone? Similar to heat transfer, this is smart transfer, right? So what is the basic thing that is causing the transfer of mass between the two systems? Sorry, I can't hear you. Can you please repeat? Okay, concentration difference. Yeah. So it's like only the concentration difference or any other difference can also play a role in mass transfer. Okay, not a problem. It's just the basic concept, like the heat transfer happens due to the variation in the temperature difference. In case of mass transfer, predominantly the transfer of mass happens due to variation in the concentration. So just for giving like a basic example, this image I've taken it from Google itself just to show it to you guys what is mass transfer means. So if you can see here, there is one molecule that is A and another molecule that is B. Okay, and if these two molecules, A represents the red one and B represents the green one, and there is a separation boundary between these two. So you can say this as a membrane or a boundary. So if you keep these two gas, you consider it as gas molecules. If you keep these two gas molecules in a container and you separate the container with the help of a boundary in between them, which might be a permeable membrane or non-permeable membrane. Okay. So in case of non-permeable membrane, what will happen is that these gas molecules will not be able to diffuse from one to another place. Why? Diffuse in the sense molecules will try to equilibrate with each other only. Uh, these two molecules will try to equilibrate only when the concentration difference, concentration in the sense, suppose the concentration of A in the first compartment, that is this, is high as compared to the concentration of B in the second compartment is low. So what will happen if we remove this boundary, that is a separation boundary or the non-permeable membrane, the gas molecules of A will try to equilibrate with the gas molecules of B until the equilibrium will be achieved. So this is what happens is that the transfer of gas molecules or any molecules, you can say the solid or any other solution, will happen from A to B because the concentration of A is higher and the concentration of B is lower. So what is happening is that the transport of species happens due to the change in the concentration gradient. Gradient in the sense the change with respect to the time. We can say, if I can say, the gas species molecules are del Ca by del T. That is the partial differentiation of A with respect to T. So this is the change in respect to time of the gas molecules A, that is transferred from the compartment A to the compartment B in order to try to equilibrate the concentration difference. So the mass transfer basically happens due to the concentration gradient, and it also happens due to the pressure gradient also. So in most of the problems you will see the only the concentration will not play a role. Apart from that, pressure gradient also plays a role. Okay, so similarly in mass transfer we will be studying this gas solid phenomena, gas phenomena, liquid phenomena, and many more, like the combinations of gas, liquid, solid, liquids, gas, many more. And suppose to that we will be always studying these distillation problems. There are many more to come in this course because it's one of the interesting courses that I have taken in my undergrad, and I still remember how this basics will help out at a later stage. Okay, so before starting the solving some like MCQs or like just to queue, so there are types of, oh sorry, so there are types of diffusion. Like I said, mass transfer happens due to diffusion because of the concentration difference from A to B in order to equilibrate the system. So then I have two types of diffusion. Like one is molecular and other is eddy or turbulent. Okay, so the molecular diffusion happens because the movement of the individual molecules on the basis of the relative of the kinetic energy. Yeah, so molecular diffusion is based on like what I have shown previously, that is from diffusion of A to diffusion of B based on the relative kinetic energy. And this molecular diffusion happens at a very slow rate. You can consider it as a laminar flow rate. But in case of this anti-turbulent diffusion, there will be eddies. Eddies in the sense, if you consider the flow of liquid and there is a plate here, so this will be eddies generated right here, so this will flow past the flat plate. So this is what is called as eddies, and these eddies will form at a turbulent flow, that is very high flow of liquids or solids. So this is what we call as a eddy or turbulent diffusion if something is going up. So there are two basic type of diffusion, like you have gone through the week 1 course, that is molecular, eddy and turbulent diffusion. Okay, now before going to the laws of diffusion. So there are two laws of diffusion that is related in the mass transfer in order to start the mass transfer course. So the first one, I will go right up here. This is just I am writing because I don't want you guys directly to jump on the numerical solutions, because I know you some of might be knowing, some of you might have not went to the lecture courses, but this will try to solve some other guys like who have not gone through the lecture notes, because just I'm just giving a quick view of what we have been done in the week one, and we try to solve some solution problems. So the first one, can anyone say what are two laws of mass transfer? Anyone? Laws of mass transfer. Okay, fix. Just pardon me because of my bad handwriting, because I'm not used to this pad actually. Otherwise, my handwriting is damn good. From the next week, I will try to make up somehow good one. So similarly, fixed first law and fixed second law. So the fixed first law, if you have gone to the lecture notes, uh, relates the flux Ja. The flux is related to the moles per area into time. That is the first transfer of moles of the species related to the particular area at what particular time is transferring. So Ja is equal to minus V del Ca by del Z. Okay. Now in this equation, the main things comes, so this is the basic starting equation of the mass transfer actually. Apart from this here itself, we can derive many equations related to the steady state diffusion and the accumular counter diffusion that we are going to see in the later weeks. So if you know this fixed first law of diffusion, what it says is the diffusion of A species A to the diffusion of stagnant species B, and the change happens to the change in the concentration gradient. So the DAB that has been mentioned here, this is different thing, this is different thing, and this is different thing. So these three things are different in this fixed first law of diffusion. That is, so this is the concentration gradient. Similarly, DAB is the diffusivity. That is a meter square per second. That is a diffusivity coefficient of A with respect to species A with respect to the species B. And this negative sign is due to the flow happen. That is the mass transfer happens from the change in concentration from the higher to the lower region. And this is basically related to the sign convention in mass transfer. Okay, so these guys, this thing you have to remember, particularly why it's minus is there, because the mass transfer happens from a region of higher concentration to the region of lower concentration. That's why we have created the negative sign. Okay, similarly there are fixed second, this is for the fixed first law. If you've gone through the notes, because I'm not going to explain each and everything, I just like to write up what are the laws, what you have gone through, and what are the basic concepts that you have gone through there, because you have to solve some problems also apart from this. And the second law, that is the fixed second law, is given on the basis of the continuity equation. So if you might have gone through the notes, there is a equation of continuity. If you take a fluid element, like I said, if you consider x, y, z axis, and if you take a fluid element, and if you take this point at x, y, z, and if you take this point, if you can say is x plus delta x, y plus delta y, and z plus delta z, and you can solve the equation of continuity. If you can take the constant density system, that you can get del ux by del x, that is the equation of continuity. So yeah, so the equation of continuity basically it, if you consider the constant density system, del ux by del x by del uy by del y plus del uz by del z equal to 0. This is the equation of continuity if you consider the constant density system. Okay, now the fixed second law can relate be on a, by using the same equation of continuity, you can derive the fixed second law, that can be given by del Ca by del theta equal to dAB, that is the diffusivity of A respect to B, del square Ca, this is the second order derivative, del x square plus del square Ca plus del y square plus del square Ca by del z square. So this is one form of the second law of fixed, that is fixed second law of mass transfer, that is relating with the help of the equation of continuity. Now there are another terms which have gone through the big notes, so I'm not going to relate each and everything of them. But what I will do is I will show you what has been done till now, or you might have gone through some of the lecture notes. So the first thing is that steady state diffusion of A through non-diffusing B. Okay, and the second one is steady state equimolar counter diffusion. So in case of the steady state diffusion of A to non-diffusion of B, if you can take NA, Now, before starting, what is Na and Ga? So, like I said, Na is the flux related to the fixed location in the space. Yeah, and Na and Ga. So, these are the two different fluxes terms which you will be relating in the later courses, tenure of the course. So, these you have to remember what is Na and Ga specifically. So, if you take steady state diffusion of A to non-diffusion of B, and as an example, if you can take absorption of ammonia from the air into the water, that can be considered as an example of steady state diffusion of A to non-diffusion B. Sorry. Okay, so it can be related as Na upon Na plus Nb equal to 1. Whereas in case of second one, that is a equimolar counter diffusion. So if you consider Na plus Nb equal to 1, equimolar means Na plus Nb equal to 1. Therefore, Na equal to minus Nb. So these two things, if you have gone, these are the direct questions that can also be asked in the gate examinations, because I've seen many questions in many of the gate chemical examinations. They have asked these questions directly. So how you can relate this steady state diffusion of A to non-diffusion B and their examples. Apart from that, they also asked what is equimolar counter diffusion from that. So this is one sort of the things which have gone through the week one course. So this is the overview of week one course. Now I will just like to you guys just to solve some of the MCQs, and I will be asking you these questions because what I have been covered is that just week one is a basic one. From week two, the main numerical solution problems will start actually. So the week one and the week assignment 0 and assignment 1 are based on this basic of the mass transfers and mass transfer solution problems. So what we have done today is that the basics of mass transfer, laws of mass transfer, that is Fick's first law, Fick's second law, and the third one is the diffusion, that is the steady state diffusion of A to non-diffusion of B, and cumular counter diffusion. So just we'll do some quick MCQs. It's just like picking up like A, B, C, D, and just see how you guys have gone through the assignments as well as through all those things. So the first one is that an insulator should have. So apart from going from some of the numerical solutions, today I have not used any numericals because I have many more numericals to come in the later course, later live interactive sessions. We will be solving some like many things using the MATLAB, Excel. I will show you guys how to use these tricks in MATLAB and Excel, and how you can get the solutions easily without going to write it numeric by hand. So like I said, because this course is not just like basically just the numerical solutions and there's the numerical problems. You guys have to know the basic concepts of each and everything what has been happening in that problem. Before going to the problem, you must know the basic concepts. That's the main concept of this mass transfer. Otherwise, many more difficulties arise in between because you will try to mess up in between. So like begin, an insulator should have. So out of these four options you can give this. So this is the simplest one I want you to guys, because I want to know at what level means the students will understand what is mass transfer and what the insulator actually means about. So uh, first of all, what is an insulator here? This is the basic question, just like within 5 seconds anyone can answer. But I wanted to, because I wanted to see how this basic questions even can be answered by the students, because it will try to create a problem in the assignments as well as into the gate examinations as well as in your like undergrad exam final examinations. Because here what I have shown is in the terms of conductivity, whereas in the examinations they will ask in terms of very different terms. So before going to the options, you must know what is an insulator first of all. Can anyone say what is an insulator? It acts as a barrier. Okay, it acts as a barrier to which, like the transfer of heat, mass. Okay, okay, okay. It acts as a resistance to the transfer of mass or heat, or it can not able to conduct anything. So there is one conductor, insulator, transistor, resistor. There are many different terms that will come up. So you can't predict whatever can be asked in the examinations, because like nowadays the examinations are like they will not ask anything, not particularly from the notes from which you have learned actually. So you might be knowing various different terms what can be asked, particularly to the mass transfer. The one particular term is the insulator. So this insulator can also be described in very different terms, like it, which is having the lowest conductivity, highest conductivity. So insulators act as a barrier in the sense, if you take two substances and this is a suppose is a barrier and you have to go from here to here, A to B, so it act as a barrier. So if the transfer of mass of A, so if the transfer of mass of A has to happen from A to B, and this is a barrier in between, so what we call is as an insulator. So it is an insulator. So it doesn't allow to transfer mass from A to B, or it's considered as a boundary. So it has a, why this mass doesn't happen, because it have a low conductivity. While here I've been asking is that in terms of mass transfer, what I've been given options in terms of heat transfer, because these two terms are somewhat related to each other. So what is the correct answer for this is, it should have a low thermal conductivity. So this is like a tricky, not a tricky question, but you should know what is an insulator first of all. What is conductivity should have been, because an insulator usually doesn't conduct anything. That is, it doesn't conduct any heat or any mass. That's why you should have a low thermal conductivity or low conductivity. Okay. So this is just the basic question I wanted you to know, because these similar terms will be coming up in the later tenure of the course. So I wanted you to get remembered from the first week itself. Similarly, this is another process, like various other process you might have gone through the heat transfer course. Uh, yeah, yeah. So how can define a non-porous structure and porous structure? So if you have gone through, like, if you can say some catalytic material, okay, and these are some of the pores, okay. If you consider this is a catalytic material and this is the surface and this is the boundary, so an insulator should have a no porous structure. But I'm not related any catalytic activity here. Non-porous structure can, if you can say if the material is catalytic active or somewhat like that, you can relate to the non-porous structure. Uh, Sorry. Yeah, yeah. So I'm not, means you can relate to that also, but I'm not particularly mentioned related to the catalytic activity of the material here. I just asked what is an insulator and how it should be. It's not related to any in the particular terms like heat transfer, mass transfer, catalytic, like in chemical reaction engineering, catalytic activity will be there for the catalytic material, and then you can see this kind of the pores. So if you can take this as a catalytic material, this will be the pores, and there will be diffusion also. There is a, in case of this, the first the molecule absorb on the surface, then it will transfer to the pores, then the reaction will be happening inside the catalytic material, then a diffusion out. So there is also diffusion happening inside the catalytic material, but that's not an insulator, because it is able to transfer to that material. What I've been given here is that it can also be a non-porous structure. It can also be a case. If it's been given more than one option, you can choose this one also. But right for now itself, it's just like a basic question that it should be a low thermal conductivity. So the second one is an azeotropic process. So what can be the main thing? This is just another basic questions, because there are many different processes like isothermal. Although they will not be studying in this course, but this sometimes might come up during the problem solving. Okay. So what is adiabatic, isothermal, isochoric, isentropic? So these are the various terms which might come or may not come in this course, but you have to be cautious while solving the problems. So like I said, just this can also be related to the heat transfer, but what we are going to study in this mass transfer, while we go through the distillation columns problems like the Macaulay method and many more, there will be many processes happening within the distillation column. That might be the process reboiler, condenser, that will come up in the later stage. I'm not going to explain each and everything here right now, but just to get an overview what this terms is all about, you have to be precautious from the week one itself. So in adiabatic process, what it can be, heat transfer, temperature change, whatever will happen. So this question is somewhat related to the heat transfer, but I'm included here because many problems are going to be happen on this adiabatic process also on later stages. Someone I've given example of distillation columns. What is an adiabatic process? Because this is just the assignment one problems, I think so. I've not taken anything from anywhere else. It might have gone through all this, because in assignments also they will not ask directly the questions what have been, you have been studied in the courses, right? It's just the assignment you have to solve. It's not like the entire each and everything will be from the course itself. You have to know the basics of the course, and from that basics concepts you have to apply and solve the problems. But before going to the problem, you might be knowing the basic terms first of all. So these are what I've been showing is the basic terms of the courses. So this is the adiabatic process. So in adiabatic process, the process happens with the help of, you can relate this with Q, that is a heat transfer. So in terms of adiabatic process, the heat transfer is zero actually. That is an isolated system. If you consider it as a heat transfer is zero. Similarly, I will show you what are the other terms like isothermal, isobaric, isentropic. There are many different terms, but I will not concentrate here because we will try to make more difficult things for you guys in the week day first itself. So that in case of isothermal, the temperature is constant. In terms of isochoric, that is the constant volume system, and in terms of isentropic, that is constant entropy. Whereas in case of isobaric, also I will say there is a constant pressure. So these are some of the terms you might have to remember during the course. Although it may come directly or indirectly, I don't know, but it may come at some point. So these things you have to remember from the first day itself. What are different these processes and how this process, if we are given a process that is happening adiabatically in the distillation column, like there is no heat transfer, so what will happen to the distillation column? Although distillation column will not operate the help of a reboiler, so there will be no process related to the adiabatic in the distillation column. But many more have to come, like if you consider gas, liquid, solid, liquid, the various different processes like leaching, extraction, liquid extraction, many more terms are there which will come in the later tenure of the course. We'll try to solve each and every problem, and in terms of that problems, this these things might show up to you guys. So you have to remember what this term is and how this, because at that time if you don't know what is an adiabatic process, what is an isothermal process, it will create problem for you guys at a later stage itself. Although I don't think so you will be facing these issues at a later stage, because only one or two terms you will be facing in the problems. So similarly, the rate determinism, like here, if you can say, I can give an example of catalytic activity of some of the catalyst. So this you can consider surface of a catalyst, and I have to give A to C. In order to get the product A to C, A gives B, B gives C plus D, where D is the undesired product and C plus D gives A. Okay, or you can relate this example with some other thing, because man, there are many different ways to in order to relate the desired product and undesired product. So in order to avoid the confusion, I will talk it out. So if you take the species A going to the catalytic surface and diffusion through the pores, okay, species A diffusion through the getting absorbed on the surface, and then it diffuses to the pores and reach at a point where the surface reaction is happening. So it's furnace absorption, surface reaction, and desorption. So these three are the different, just an example for what is the rate determining step and which is the slowest step. So this is the absorption on the surface, this one that is going from A to B, B in the sense you can consider here, and then B is going to the point at which the catalytic activity will be happening, that is conversion of the desired product, that is B to C. So if you can say A gives, B gives C. So A getting absorbed on the surface, that is at B, B getting converted into the product C inside the material, and C get dissolved from the inside the material to the outer surface, that is C. So C is the desired product. So what will the desired product step, that is the reaction step, and basically you have heard. So if you can see, the main step here is the surface reaction. This is the main step, and this absorption and desorption happens very fast in some of the processes. So in particularly in general, if you take the rate determining step, it should be the slowest step, that is the surface reaction step. So what I've been asked is the rate determining step in the reaction consisting of number of steps in series, like I said, A gives B gives C, and you can also say relate to some of the side products give D. Okay, so the number of steps, the rate determining step that is happening in a series can be related to a slowest step, that is the surface reaction. I've given with the help of an example. So it should be a slower step in series. Okay, so this is how you can relate the various examples which have already gone through some of the courses. So this is one of sort of example I've given in order to relate this MCQ. So I think this you guys can give an answer. Just I've gone through this fixed first law, right? So can anyone say what is the correct answer for this one? Because as already given the fixed first law and fixed second law and equation of continuity we have already seen. So okay, if someone is having problem, I will say what is fixed first law that is related to the flux is equal to minus dAB, diffusivity of A species A respect to B del CA by del Z. Here del C by del Z is the concentration gradient. So you can see the options that is A, B, C, D and try to relate this equation with these options given. So what is the correct answer? So the diffusivity that I am mentioning is this one, that is dAB. Okay, and relate all the four options given in the question. So the diffusivity decreases with increasing temperature, increases with the molecular weight, and increases with the size of the individual molecule. So what will be the correct one, or D, none of the above? You can directly read this equation from all the four options easily. Anyone knows the answer from out of this four, what will be the correct one? None of the above, okay. Because you can see the fixed first law relates the diffusivity and the concentration gradient with the molar flux of A. Okay, so we can't say anything that is the temperature has not been involved in this. There is no molecular weight in the individual molecule. You can relate diffusivity only with the flux as well as to the concentration gradient. That is this concentration gradient. So the answer will be none of the above. So this is indirectly been asked to you guys in the assignments also how you can relate, because if you don't know what is fixed first law, you will not be able to solve this equation. And this type of questions can also be asked in the gate examinations, and I know this kind of questions has been asked already like 2 to 3 times. Similarly, on the fixed second law, they have been asked many questions. So if you know the basics, like what is fixed first law, what is fixed second law, what is equation of continuity, and how fixed second law derived from the fixed equation of continuity using the various derivations like taking a fluid element and taking a different positions like point x, y, z, or x plus delta x, y plus delta y, and z plus delta z, you'll try to solve out all these equations easily. Yeah, similarly, this is what just like I mentioned previously. The fixed first law, there's the flux of A is related to the diffusivity of A with respect to B, and its negative sign is there because the diffusion happens from region of higher concentration to the region of lower concentration, and del C by del Z, that is the partial differentiation of A with respect to the distance Z, that is the concentration gradient, where dAB can be written as, what is dAB first of all here? I just mentioned in the previous slide. Anyone can speak out, it's not a problem. See, if it doesn't speak, that might create problem for you also, because if you speak out, I might be able to give you some options. I might be able to help you out in some of the things, because this is just in week 1 course, so I'm just showing the basic concepts like the fixed first law, second, and all the things. Diffusion, okay. DAB can be called as a diffusivity, diffusion constant, or diffusivity of A species A with respect to the diffusivity of B. So the correct answer will be C, that is both A and B. Okay, so if I can say instead of DAB, I can write DBA. It is the diffusivity of B with respect to the in mixture of A and B. That is, this will be the correct answer for this. Okay, and it can also be said as a diffusivity coefficient. So what I've given here is one thing I've not given here. What is the unit for the diffusivity? Unit for DAB. This is also one type of question I wanted to ask you guys, because already been I've said flux, diffusivity coefficient, and the concentration gradient. Can anyone derive this unit for the DAB from the above equation? Or if you don't want to derive it, you might have gone through the lecture notes, right? It's just the basics. That's not a problem. Although not a just hard and fast rule. It's in meter square per second. So this unit will play a role in the later cases because we will solving some of the problems related to the steady state diffusion and of A with respect to non-diffusion B and equivalent counter diffusion. And when we try to solve out this flux, that is the flux of A or flux of B, using these two like steady state and equivalent counter diffusion, that DAB will be coming. And in some of the questions, the value of DAB will be in centimeter square per second or centimeter square per hour. So you have to convert that into the SI units first of all, then you have to try to solve out. Because if you have taken the units directly from what I've been given in the question and it's not as per this, the answer what you are right will be wrong actually. So you must know what are the SI units of the diffusivity that has been mentioned. Okay, like I said, there are two types of diffusion: molecular diffusion, eddy diffusion, and turbulent diffusion. So the transport of molecules from a region of higher concentration to lower concentration in turbulent medium is called as D. This I've already covered in the previous because I wanted you guys to know what is diffusion and what is the basics of this course actually. If anyone is thinking I'm not showing any numericals, it's because this is a big first on it because I wanted you guys to know what is the basics of the mass transfer. I have many questions lined up with the MATLAB coding as well as from the Excel sheets and various other things. I know Python also, but it might be difficult because some of you might not be knowing. But we'll be solving various numerical problems from the next week. Apart from that, I'll be showing how to do some simulations in the distillation columns at a later and towards the end of the course. But this first trick, I just wanted you to guys to remember what is mass transfer, laws of mass transfer, there is fixed first law, fixed second law, what is equation of continuity, and how to relate equation of continuity to the fixed second law, and the steady state diffusion of A and cumulative counter diffusion. So the transport of molecules, like someone said, the correct answer is D. Yeah, the correct answer is D actually because in transfer of molecules from higher, it generally happens from the higher to the lower concentration, and we have the negative sign convention for that. As you can see, J equal to minus of DAB. This minus is a sign convention because the transfer happened from region of higher to a region of lower. But here what I have given is the turbulent medium. Okay, in case of turbulent medium, if I gave you the laminar flow, what will be the correct answer? For turbulent medium, the eddy diffusion or turbulent diffusion is the correct answer. This is for turbulent medium. For laminar flow, what will the region from higher concentration to lower concentration? It can be called as what kind of diffusion? Like I said, there are two types like molecular or eddy or turbulent diffusion. So that if someone happens with a very small flow, like if you can say the flow is not that much dominant, it's in the region between the laminar, you can consider it as a molecular diffusion actually. So the flow is very slow in case of molecular. The diffusivity of gases is related to the average relative kinetic energy of the molecules that are said in the first line itself, the molecular diffusion. So it can be related to the molecular diffusion. So sometimes this term might trick you out in the final examination or the assignment problems because someone will directly see what is turbulent medium and try to take up the questions. But in some cases they will try to trick you out with so that both the terms in the same question and try and they'll ask you what is laminar flow, what is turbulent medium flow, and how you can relate this both the flow mediums with the diffusion types in the mass transfer. So you have to be cautious with dealing all the cases. Now this is one of the easiest one. Like I said, there are two types. Like the first one is steady state diffusion of A through non-diffusing B. So in this we can take as the flux of A divided by flux of A plus flux of B equal to 1. Where in case of second, that is steady state equimolar counter diffusion. So equimolar if you can take A equal to B. So flux of A plus flux of B equal to this. So Na equal to minus Nb. So you can take flux of A equal to flux Na equal to minus Nb. And they have asked in the equation the ratio of Na by Na plus Nb. So we can say Na upon Na plus Nb equal to Na upon 0. So we know that 1 by 0 is infinity. Okay, so this will be infinite. So the correct answer will be C. So this is somewhat related to the steady state diffusion fluxes and the steady state diffusion of A. Although these two have their own different formulas to relate with, because that might be coming in the second week of the course, and from that you can find the various parameters like the pressure and many more. How this pressure happens with the help of the distance. Like there is one graph which relates the pressure with the distance, that is Z. So there are two type of graphs. One is like this, and one is like this. So this is for diffusion of A to non-diffusion B, and this is for the equimolar counter diffusion. That is two different species, A and B. So this you guys must have already gone through, but I'm not including the week one course because it will try to like jumble up all the things in one go. So week one is all about the basics and first law, second law, diffusion of A to non-diffusion B, and that up. From second week, what we will do is that I want you guys to go through all the assignments. That is assignment 1, assignment 0 is also there, assignment 1, and assignment 2 has already been uploaded in the NPTEL portal. So if you go through all the assignments, you might have seen the various problems which carries 5 marks, 2 marks, and 1 marks also. So I want you guys to solve each and every assignment problems. And if you face any difficulties prior to the assignment problem, you can ask in the second week of the live interaction that is going to happen in Saturday 3 to 4 next week. Prior to that, what I will do in next week is that I will try to solve the numerical problems, that is big numerical problems that has been taught already in the lectures, that is week 1 and week 2. So today I have not included any big numerical problems. It's just because it's the week 1 starting point of this course. From the week 2 we'll start solving each and every numerical problems. Apart from that, I'll be showing you how to solve some of the problems using MATLAB and Excel. That will come in the later duration of the course, that is using the distillation columns problem. But before that, we'll solve the problems related to the assignment. Apart from the assignment problems, I will also give some of the problems related to the GATE examinations, because some of you might be sitting for the GATE examination at a later stage, like 1 year, after 1 year, after 2 years also. So it will be helpful for you guys to compensate from the now itself, solving some of the problems related to the GATE, because this mass transfer course has a weightage of all about 8 to 10 marks in the GATE examination also, and in the final examination also for the NPTEL, it's one of the major course that is considered as a core course for the chemical engineers. So we'll try to solve out some of the GATE's problems as well as the assignment problems from the next week. So this is what I have for today, just the basics and all the things. Apart from this, I want you guys to speak out anything from the course what you have already gone through from the week on one, week two. So how did you guys like the course, by the way? First of all, for the week 1 and week 2 has already been uploaded. Or you face any difficulty issues related to the week 1 or week 2 or the courses? I think everyone knows each and everything for the mass transfer from week 1 and week 2. That's why they're not saying anything. No problem. Okay, great to hear that. Because I know the problems will come up at a later stage, because this is just the starting and mass transfer is not that easy, which if you are thinking from the first stage, but it's good to see like someone is saying no problem, because they might have understand each and everything. But I want you guys to go through the lecture notes again and again, because if you try to build up all the things at a later stage, it's better to solve the assignment problems week after week, what has been given, what has been taught. If you go through like weekly, it will be better for you guys in the final examination also. And apart from them, you might have also seen the reference books for this. That is what I prefer is the Trebal, Robert E. Trebal. There is Tata McGraw-Hill third edition. I'm preferring that from my undergrad studies, and still I'm going to learn more and more about that book. So it's very good reference books, and I will suggest all you guys to go through this Trebal only. That is Robert E. Trebal first of all. Apart from that, you can go through any reference book that has been mentioned in the NPTEL portal. And if you want to any other reference books, you are free to use, because but basically what as a standard book, what we prefer is the Trebal. So I would like to prefer Trebal as a standard book for the mass transfer. So if in any case you guys have any problem related to the assignments or anything that you want me to cover up during the live interaction sessions, please let me know through the forums that have already been there in the NPTEL Swam portal. And you can also ask the same questions in the NPTEL Swam portal. So for this week, I have only for just like the basics of mass transfer and the things I would like to cover. I'm eagerly waiting for the week two to start up because week one is just the basic, just what is mass transfer, laws of mass transfer. For week two, we'll start to cover up like we'll try to solve out very basic numerical questions and we'll try to get more and more interested in that. Sora, yeah, please go ahead. Yeah, okay. Okay. So, like, so when is this assignment due date? First of all, I can say the answer. I've already shown the diffusion of non-diffusion B. When is the assignment one due date? First of all, 10th of August. Okay, so I can say the answer directly to you, but like I've shown to you, if you can, I've shown. That's what I'm saying. I've shown you two different figures here, right? This is for study. The what I've you asked is the diffusion of A to non-diffusion B. That is this one. Like I show the plots like this. And you have also gone, if you also go through a table, they have mentioned the specific thing directly in one line. You will get the directly answer from that actually. So if you can take two different species A and B diffusing to this, so if you can say A is going from here and B is going from that side, and the consideration of A is maximum one here and zero here, and similarly for B is one here and zero here. So in between there are the various concentration, that is XA and XB. You can consider mole fraction also or the mass fraction also, what you can say. So by looking at the like I said, there is one equation for that also. I didn't given it the equation here because I wanted to cover in the second week, because this assignment due date is in 10 August. That's are not included the equations here. From that equation you can also relate the partial pressure from this variation in the distance, that is z, that is mentioned here, and how to relate this pressure distance z with the pressure gradient and both the species. So if you look at that equation specifically, and the explanation of that equation will try to solve the equation within 1 second actually. That's not the case actually. So I will suggest you to go through this lecture notes first of all, because I can give the answer directly within one go. Because if even if I give two explanation, that's an answer itself. So I don't want to give that in the live interaction. So I just like to suggest you guys just go through this, like the steady state diffusion of A to non-diffusion B, and they have the two different equations which will cover up in the second week. Okay, so what I will suggest is that go through these equations and try to read out what have been how they have derived this equation, because while deriving this equation they have mentioned some particular things, and once you look at the particular thing, that is the particular answer of that question what you have been asking actually. So that's what I've been saying. Go through the like week lecture notes specifically. Try to go like, even if you go through one time, you will not be able to solve any and all the questions within one go, because the basic concepts matters, and that's what I've been saying from the first point. Go through the lecture notes again and again. Even if you take more than 1 hour to go through like a week one lecture notes, go through once through more of them. Okay, it's better to go through this one more time, and let's see. From week second, I will try to include these equations like I said previously. Anyone have any suggestions for me? Like my speaking skill is like too fast, or someone is not able to understand. They can speak up freely because I'm also a student. It's not a matter that I'm a professor here. So everyone found my speaking like speed is good, or shall I need to uh, lower it down? Yeah, yeah, yeah. Yeah, I understand because even my professor used to say please speak slowly. So that's what I wanted to ask if someone doesn't understand what happens. It's literally a flow like that. So it's not a problem. I will try to speak slowly from the next time. So thank you guys. Thanks for the suggestions. Thank you so much. Yeah. Thank you, thank you. So from the next week, like on next Saturday, we'll meet up at 3 to 4, and we'll be solving like some big numerical problems. So I'll be solving by hand instead of my pad. And in that problem, if you have any issues, please let me know. Prior to that, if you have any issues, please post in the forum on the NPTEL Sun portal. Okay, and you can also mail to the NPTEL team for any queries related to your course. Actually, thank you so much, guys. Thank you so much for attending. We'll meet next week at the same time, Saturday, 3 to 4. Thank you so much, guys. Thank you.